Hello everyone. In this video, we will take a brief look at how to invoke sub-circuit libraries in SPICE for those circuits or components for whom the inbuilt library is not there in the SPICE simulator. For example, the 741 op-amp, that is a very popularly used op-amp in the lab and in various applications, but SPICE does not have the inbuilt library for it. So therefore, one of the easiest ways to use the 741 in SPICE is to obtain the library file of the subcircuit for the op-amp from the manufacturer. So say, for example, I have already obtained this file over here, which you see is lm741.lib. This is the original file for the 741 that is provided by the manufacturer. So one thing that you can do is to quickly open this library file using a text editor. And you can see that there is a description over here. So this is the most important line which tells you about the subcircuits LM741. And interestingly, what you see is this subcircuit has 5 terminals. One for the non-inverting input of the op-amp. Next is the inverting input. The next two are for the positive and negative power supplies, that is plus VCC and minus VCC respectively. And finally, we have the output. So therefore, without any further ado, let us open LT-SPICE. And I'm going to open a new schematic. First things first, I'm going to save this schematic in the same directory where my library file for the op-amp 741 is saved. That is over here. So let us say I want to design the circuit of an inverting amplifier. So I will give the name inverting amplifier and save it accordingly. Now, what I will do is I will go to component and then I will click on op-amps. You will see a list of op-amps which are not going to be required by us for now because they are not 741. So we will scroll onto the very right hand side and we will see that there's this component called as op-amp 2. Interestingly, you see that it has 5 terminals, each marked with a square. That is the 2 inputs, the 2 power supplies and the output, just as the way that is described in the library file that we just saw. So just to brush it up again, these are the 5 terminals. Notice the name of the subcircuit, that is LM741. This is very, very important. And that is the name which we shall be using in our simulator 2. So I will click on this. I'll say OK. And I'll paste it into my schematic. Now I will right click and I will replace the value of the op-amp by the name of the subcircuit that was in the file, which is LM741. So I've done this. The next step is very important. That is to invoke the library file into the schematic. So for that, I will go to this option called as SPICE directive and I will write a command that is .include. The dot is very important, followed by the name of the file. Now, the name of the file is lm741.lib. So be very careful with the name and the extension. Now, if this library file were to be saved in some other directory, then you would have to include the entire path for that directory. So that's why saving the schematic and the library file in the same directory has its advantages. So I'll say OK, and I will paste it somewhere over here. Now, very quickly, I will make the inverting amplifier circuit and I can do it this way. First, I will connect 2 DC sources for the plus VCC and minus VCC respectively. So one over here the other over here. I will use 12-volt sources for my VCC and minus VCC. I'll place a ground over here. So let's quickly do the connections. Now, the moment I take the V1 plus terminal, it becomes plus 12. And I take the minus terminal from V2, it becomes minus 12. And my supplies are now ready. Now I will use two resistors to make an inverting amplifier of gain 10. One is over here. The other I will place over here. So right click, R1 becomes 1K, R2 becomes 10K. And the plus input has to be grounded. There we go with the connections. Finally, we need to connect an AC source for the input for the amplifier. So what I will do is, again, I will go for a voltage and I will give a sine wave, which is 1 volt peak to peak. That is 0.5 volts in amplitude. So I'll go to advanced. I'll choose sinusoid. Amplitude is 0.5 volts and a frequency of 1 kilohertz. So I will complete this remaining connection. And our connections are done. So now we are almost ready to simulate. Only we have to specify the type of simulation. Since we want to see transient analysis, let's observe 10 cycles of the waveforms, both input and output, with a resolution of 0.02 milliseconds. So we are now ready. So for better clarity, let's change the plot window a bit. So I'll choose the color preferences for the background. I'll make it white, which makes it easier to observe. And thereafter, I will choose the trace width as 3, so as to observe it slightly thicker. So now let's first observe the input. So the input is as expected, 1 volt peak to peak. So that means 500 millivolts in amplitude. And the output, it's now time to see whether we have done it correct. The output is this blue trace. As you can see, it is 10 volts peak to peak. So therefore, if the output is 10 volts peak to peak and the input is 1 volt peak to peak, the gain is 10 in magnitude. It's also interesting to see that the input and output are out of phase by 180 degrees. And that is because the gain factor is actually minus R2 by R1 in the case of the inverting amplifier. So with this, we see a very basic example of how to include subcircuits using library files for different types of components. This can also be used. So I now invite you to try this out yourself and start exploring with other subcircuits and components as you would need to.